In the silence of deep space, something is keeping time. Not a star, not a planet, not anything we can point to and name. A signal, a burst of radio energy so powerful that in a single millisecond it releases more energy than our sun produces in an entire day. And then it does something that should be impossible. It comes back again and again, on a schedule, every 157 days, like a cosmic alarm clock buried somewhere 3 billion light-years away. Scientists have spent over a decade trying to explain it. They have theories, they have models, they have supercomputers, and they still don't know what it is. This is the Earthling Files. To understand why this signal fascinates astronomers, we have to go back to 2007. A researcher named Duncan Lorimer was sifting through old data from a radio telescope in Australia, archived recordings nobody had bothered to fully examine. And buried in that data, he found something that lasted just 5 milliseconds. A spike, a burst, brighter than almost anything in the sky, and then gone. They called it the Lorimer Burst, and for years most scientists assumed it was a glitch, a fluke, maybe interference, and in fact, one later source of false signals turned out to be a microwave oven in a telescope facility. The field was embarrassed. Nobody wanted to chase ghosts, but the bursts kept coming. By the 2010s, telescopes around the world were catching them, quick, violent flashes of radio energy arriving from impossibly far away. We named them fast radio bursts. And here is the first thing that should make the hair on your arms stand up. Most of them happen exactly once. One flash, one direction in the sky, never to repeat, which means we can never go back and study them. We catch them by accident, like seeing a single firework explode over a city you'll never find again. Astronomers estimate that thousands of these bursts are going off across the sky every single day. The universe is flashing in a language we cannot read. And then, in 2016, one of them broke the rule. It was given a name that sounds like a case file, FRB 1211102. Unlike every burst before it, this one repeated. Not on a schedule at first, just clusters of bursts erupting from the same point in the sky, over and over. The same coordinates, the same distant source. This changed everything. Because a repeating source is something you can study. You can point telescopes at it and wait. So they did. They traced it back to its home, a small, faint dwarf galaxy, roughly 3 billion light-years away. Let that distance settle for a second. The light and the radio waves we are detecting now left that galaxy long before our Sun and Earth existed. We are reading a message older than the ground beneath you, but the location only deepened the mystery. Because whatever is producing these bursts sits in an environment of almost unimaginable extremity, a place wrapped in magnetic fields vastly stronger than anything we can produce on Earth. And then researchers studying these repeating bursts noticed something nobody expected: a rhythm. When astronomers tracked the activity of this repeating source over long stretches of time, a pattern emerged from the noise. The bursts weren't random. They came in windows. The source would switch on, firing off bursts for a stretch of days, and then go quiet. And then, predictably, it would wake up again. For FRB 1211102, the cycle clocked in at roughly 157 days. A long active stretch, then silence. Like something breathing, like something orbiting, like something turning to face us, and then turning away. Now, here is where we separate what we know from what we're guessing. We know the timing is real. Independent teams have reported periodic windows of activity in repeating bursts. That part is taken seriously. What's in dispute is the why. So let's go through the suspects, because every good file needs a list of suspects. Suspect 1, the magnetar. The leading natural explanation is a magnetar, the collapsed dead core of a massive star, spinning fast and wrapped in one of the most powerful magnetic fields in the known universe. In 2020, astronomers caught a burst coming from a magnetar inside our own galaxy, the closest thing to a smoking gun we have. If a magnetar is the engine, the 157-day rhythm might come from the star wobbling or from a companion object pulling on it as they orbit. It's the most likely answer, but most likely is not the same as proven, and it doesn't explain everything. Suspect 2, the orbiting pair. Maybe the source isn't alone. Picture a magnetar or neutron star locked in orbit with a massive companion, a giant star bleeding out winds of gas and dust. As the two circle each other, the bursts can only escape during part of the orbit, when our line of sight isn't blocked. The 157 days in this theory isn't the object breathing. It's an orbit, a cosmic dance, and we only see the bursts when the partners face us. Suspect 3, the one nobody wants to say out loud. Whenever a signal from space is precise, repeating and patterned, one question always surfaces. The question every scientist is trained to rule out last, but that every human asks first. Could it be artificial? Let's be honest and careful here. There is no credible evidence that fast radio bursts are a technological signal. The energy involved is staggering, far beyond anything we could build, and natural objects are very good at producing rhythms. Pulses beat like clockwork, and they're entirely natural. But the reason this question won't die is simpler than aliens. It's this. We are detecting an organized, repeating pattern from across the universe, and our best minds still argue about the mechanism. The honest answer, the one that should unsettle you more than any alien theory, is that the cosmos is running processes we have not yet learned to name. Here's the part that elevates this from a curiosity to something genuinely profound. These bursts are becoming tools. Because each one travels billions of light years to reach us, it passes through all the invisible matter scattered between galaxies, matter we previously couldn't account for. By studying how the bursts smear and slow on their journey, astronomers have started using them to weigh the missing matter of the universe itself. Think about that. A signal we cannot fully explain is helping us map the parts of the universe we couldn't even see. The mystery is becoming a measuring stick. And every time one of these sources wakes up on schedule, somewhere on Earth, a telescope turns toward it, and a scientist holds their breath, wondering if this is the cycle where the pattern finally breaks, where it does something new, where it answers back. 3 billion light years away, something is keeping time. We've given it a name. We've built theories around it. We've used it to glimpse the hidden architecture of the cosmos, but we still cannot tell you with certainty what it is. And maybe that's the most important file of all, proof that the universe is still full of signals we're only beginning to hear. If this rewired the way you see the night sky, you know what to do. Subscribe and keep the files open, because the next signal is already on its way.